Everyone, so if you have not yet subscribed to my channel, kindly do so. Press on that button which says subscribe. Today we're looking at question 15 from tutorial sheet 3. Okay, so question 15 tutorial sheet 3, question 1 is saying find the set of values of x for which this is less than x minus 3 over x plus 3. So here what you can simply do is, if you want, you can just cross multiply from there. Though some people say cross multiplying using what's this, when you're dealing with intervals is not allowed, but sometimes it works. But if you want, you can cross multiply, or you take this part to this other side, you take it to this side, and then you begin to work it out. So the simplest way you can go with this question is just by cross multiplying. So when you cross multiply, when you cross multiply this times that and this times that, you're going to have x times, okay, let me do this. So we're going to have x plus 3 in brackets, and then you're multiplying it with x plus 1. So this is less than x minus 1 multiplied by x minus 3. So this is what you simply do. Okay, so this is what you simply do. So you start multiplying now, you expand this, so it's going to be x times x, there you get x squared, then x times 1 you get 1, you get x, and then 3 times x you get positive 3x, and then 3 times 1 you get 3. So this is less than x times x, there you get x squared, then x times negative 3x, x times negative 3 you get negative 3x, negative 1 times x you get x, negative 1 times 3 you get positive 3, negative 1 times negative 3 you get positive 3. So here it's just a matter of pairing the like terms. So you take this x squared to the other side of the equal sign. It's going to be x squared minus x squared, which will give you a 0. So you leave that part. So we add x plus 3x, we are going to get 4x, and then plus 3 being less than, we're going to have negative 4x. This one and that one have already gone, so we are just remaining with negative 4x here, which is negative 3 minus x, negative 3x minus x, you are going to get negative 4x, and then this 3 is going to be, you write it the way it is. So again, you pair the like terms. You take this negative 4x to the other side of the equal sign, you are going to have 8x, because negative, when it crosses the equal sign, is going to be a positive. So we're going to have 8x, which is less than this 3. When it goes to the other side of the equal sign, we'll have 0. It's going to be 3 minus 3. So you divide by 8 this side, divide by 8 this side, meaning the values of x, the range of values of x that we need is just x less than 0. So meaning you can write this as, so if you want, you can write this as x is equal to, so we're saying x is less than 0, so meaning we're coming from negative infinity to what? To 0. So do this, because we know to say 0 is also not part of the solution set. So this is what you get. So you can either write it like this or like this, you still get the same answer. And then I heard somebody complained on the the description, say I should be using white paint, not red. They are not able to see clearly with red, so let me just change the ink color. Okay, So now this is how you solve the first part. Let's move on to the second part. So the second part of the question is saying it's telling us to say this x squared plus 7x plus 10 over x plus 1 is less than, is greater than 2x plus 7. So here what you can do also, you can cross multiply, there is no problem. So we know to say this 2x plus 7 is less than, is over 1. So we cross multiply 1 times that quadratic equation, which is the numerator, this part here, which is the numerator. So when you multiply that by 1, you still get the same thing, which is x squared plus 7x plus 10. Then when you multiply these two, x plus 1 and 2x plus 7, this is 10, and 2x plus 7, you are going to have x times 2x, you are going to have 2x squared. X times 7, you get positive positive 7x, and then 1 times 2x, you get 2x. 1 times 7, you get positive 7. So now here is just a matter of pairing the like terms. So what we're going to do is we'll take all these to the other side of the equal sign. So we're going to have this x squared minus 2x squared. X squared minus 2x squared, we're going to have negative 2x, negative x squared. X squared minus 2x squared, we're going to have negative x squared. And then we have 7x. So 7x minus 7x, this one and this 7x here will cancel. So meaning will just come and remain with negative 2x this side. Negative 2x. When this 2x crosses the equal sign, we have negative 2x. Then we have 10 minus 7. So 10 minus 7, we have positive 3 there. So we'll say it's greater than 0. So here what we can do to simplify our expression is we divide by negative 1. Everything we divide them by negative 1. But remember, every time you're dividing by negative 1, the sign here, when you're dealing with inequalities, the sign here will change. So we're going to have x squared plus 2x minus 3 to now be equal to, to now be less than 0. So here it's just a matter of factorizing this. You find the solution to this. So you can agree with me to say the factors will be negative x, which is negative 1, and positive 3x minus 3 less than 0. So for the meantime, if you want, you can continue using this less than symbol, not greater than. Sorry, I made a mistake. So you can continue using this less than symbol, and then at some point you will have to come and equate it to 0. So what you do is you factorize this. So we're going to have x minus, you say x, open brackets, you have x minus 1 plus 3, then you have x minus 1 like that, and then you have x minus 1 there as one of your factors. You also have another x plus 3 there. So what you do with these factors, you do as this, you equate this to 0. So you can say let this part, actually we're supposed to do this on this, just after this point we're supposed to equate this to 0. So I was saying at some point you'll have to equate it to 0. So you equate this x to 0, x minus 1 to 0, and x plus 3 to 0. Okay. yeah, to 0. So meaning our values of x that we're going to have are, let me just do this. The values of x that we're going to have, the first value of x will be positive 1. The other value of x is going to be negative 3. So these are the values of x that we have. So what is just now remaining of us to do is to find the interval, the values, the set of values of x that are needed. So what we have found here are called critical points. So what you have found here are called critical points. These are just points. So now it's now the time for us to find the values of x that are needed. So these are just critical points. They are not the numbers that we want. So you are going to put your negative 3 there. You put your positive 1 there. So we know to say all numbers that are this side are less than negative 3. So we're going to say x is less than negative 3. And then here, the numbers between here are between negative 3 and 1. And then this side, we're going to have all numbers which are greater than 1. So we begin to test the intervals by getting this part here. You get this part, then you use this symbol now. So we're going to have x minus 1, and then we say x plus 3. We use that symbol there. So we begin now to test these values. How do we test? It's simple. So you get any number that is less than negative 3, so we can get negative 4. So when you put negative 4 here, it will be negative 4 minus 1, which is going to be negative 5. So I'll not write negative 5, but I'll write the symbol there, a negative. And then I'll put negative 4 there. Negative 4 plus 3, I'm going to get negative 1. So instead of writing negative 1, I'll write a negative answer there. So negative times negative, you get a positive. We move on to the second part. So the second area, the second part here is saying numbers between negative 3 and 1. So we can even get a 0. So we put a 0 there. 0 plus 1, 0 minus 1, it will give us a negative 1. And 0 plus 3 will get a positive 3. And then negative times positive to give us negative. Okay. So we move on to this other side. We get any number that is greater than 1. We can even get 2. So 2 minus 1 will get a positive 1. So I'll write the positive there. Then 2 plus 3 will still get a positive. Positive times positive, yeah, so positive times positive there will give us a positive. So what is now needed here is to check, is a positive number, we start with this part, is a positive number less than 0? No. So this part has denied. Move on to the second part. Is a negative number, meaning our answer here, is it less than 0? Yes. Negative is always less than 0. So what of this part here? Is a positive number less than 0? No. So even this part has denied. Meaning the values of x that are needed, or that these people need from us, are just simply, let me just say, I'll write them in this box. So the values of x that they need are just equal to, so starting from negative 3 up to where? Up to 0. Oh, sorry, don't know where I'm getting this 0. So starting from negative 3 up to 1, you just get this same set interval here. So up to 1. If you want, you can just write this same interval here. Just repeat it. You just say, okay, the range of values of x that are needed are from negative 3 up to 1. So this is the answer that we need, which can also be written as that in set builder notation, also in set interval notation. So we quickly move on to the next question. So these questions are simple and they are straightforward. You don't need to stress in when solving these questions. Move on to the next question. So okay, I'll also solve this one. Once I solve this one, maybe I'll also pick one of these, because how to solve this is not a problem. It's not very much a problem. So since you've known how to find the intervals when you have been given a quadratic equation, so it's even easier for you now to solve these questions. Let us now quickly move on to the next question. So our next question is negative 1 less than 2 minus x over 2 plus x, which is less or equal to 1. So how do you solve such a question? It's simple. You first take the first part, meaning you are going to take this part first. You take this part. So we'll first deal with the first part, which is this negative 1 less 2 minus x over 2 plus x, and then the second solution, we're going to get 2 minus x over 2 plus x. There's a plus here, and then we say it's less or equal to 1. So now from here what we do is just to solve. So we can cross multiply there. We're going to have negative 2 minus x being less or equal to 2 minus x. Yes, so we can pair the like terms here. So when you pair the like terms, you discover that this x and that x will cancel. We're just going to remain with negative 2 less 2. So this has no solution. So this part has no solution. Let's quickly solve the second part. So when you cross multiply there, we're going to have 2 minus x less or equal to 1. 2 times 1 there, you get 2, and then x times 1, you get x. So when you take this to the other side of the equal sign, you're going to have 2x. Okay, let me write it this way. So when you take this 2 to the other side of the equal sign, you are going to have a 0 this side. It's going to be 2 minus 2, which is 0. When you take this negative x to the other side of the equal sign, you have 2x, because it's going to be x plus x. So when you switch these, you can write them as 2x greater or equal to 0. So meaning the value of x when you divide by 2 on both sides there is nothing but it's nothing but 0. It's going to be 0. So this interval is only valid when the values of x are greater than 0. So you can test it. Try to put any number that is greater than 0 there. So we're going to have negative, we'll put maybe a 1 there. So 2 minus 1, you get a 1 over 2 plus 1, you get a 3. Is negative 1 less than this? Yes, it's correct. And is it less than 1? Yes, it's correct. So that is how you prove that your solution is correct. Okay, let's quickly solve another question. So the other question that we have is D. So D is saying we solve 8 minus 2x minus x squared. So remember how we solve these absolute value intervals is so when you have absolute value notations, remember how we're solving this. You first write the positive one. So our positive one is just going to be 8. and our negative 1 is going to be 8 minus 2x minus x squared less than negative 8. So you take this 8 to the other side of the equal sign, you just remain with 2x minus x squared less than 0. So how can you write this? You are going to have, you factorize this. So when you factorize, you are going to have negative x to be common there, then you have a positive 2 there, and then you have a plus x being less than 0. So you equate this to 0. So when you equate this to 0, you find your critical points. Our first value of x is just going to be equal to 0, and then our second value of x is going to be equal to negative 2. When you equate this to 0 and that to 0, so you get negative 2. So these are just critical points. So how do you now work them out? It's simple. So you're going to write your negative 2 there, and then you're going to write your 0 there. So you write the way we wrote the previous question. You say this side x is less than negative 2, and then here x is between negative 2 and, so x is between negative 2 and 0, and then this side x is greater than 0. Then you begin testing them. So you test this part. So you test this part, you get negative 3, put negative 3 there, you're going to have positive 3 times 2 minus 3. So positive 3 times negative 1, you get a negative answer. So we have a positive this side, and then times 2 minus 3 is negative. So when you multiply the 2, you are going to get a negative answer. So same applies on the middle part here. You do the same. You get a number between negative 2 and 0. You can even get negative 1. So when you put negative 1 there, you get positive 1. When you put negative 1 there, 2 minus 1, you get a positive. So when you multiply the 2, you still get a positive. You get a number greater than 0, you can even get a 1 there. So when you put a 1 there, you get a negative answer. When you put a 1 there, 2 plus 1 is a positive answer. When you multiply the 2, you get a negative solution. So is a negative solution less than 0? Yes. Is a positive solution less than 0? No. Is a negative solution less than 0? Yes. So you get these two. So the intervals of our first part there that we have are x is less than 2. So we have x is equal to, so x is less than 2, meaning negative infinity, comma 2. Oh, sorry, say negative 2. And then we say union we have 0 up to positive infinity. So this is our first interval that is needed. Let us also work out the second part. So the second part, we're going to have something like this. When you simplify this, it's going to be 16. Okay, let me write it here so that we create some space. it's going to be 16. When this 8 comes to the other side of the cosine, you're going to have 16 there, minus 2x minus x squared is less than 0. So when you divide through by -1, you are going to have x squared plus 2x minus 16. Since we have divided by negative, this sign will change. So from there now we can start solving that. Which two numbers can we multiply to give us -16? When you add them, they'll give us 2. Yeah, so these x values that were found, we call them x1 values. So what we're going to find are x2 values, and then to find the final values of x that have been asked in the question, we simply find the intersection set between the two. So first, let us find the values of x for this one. So if I fail to find the factors, then I can use the formula method. If not the formula method, I can complete the square. So let me just use maybe the formula method there. So the formula method states that x is equal to -b, which is -2. Then we have plus or minus the root of b squared will be 4 minus 4a is 1, then c is -16 over 2a. So 2a is simply just 2. 2a is simply just 2. So this is going to be x is equal to -2 plus or minus. So when you simplify what's in the brackets, there are 4 times 16, you get then this is what you're going to have, and then when you simplify that, you get something like 68. Yeah, 68 there. And then everything divided by 2. So this 68 can also be written as I think 4 root 17. Yes, so this can be written as 4 root 17. So we can say x is equal to -2 and then plus or minus 4 root 17. Everything divided by 2. This is 2. So the values of x there will now be equal to -1 plus or minus 2 root 17. So these are our critical points that we have found. We can also now take them on the number line. Let me just erase this on top. So those are the critical points that we found. So we just take them on the number line now to find the intervals. Okay, so those are the critical points. So we take them on the number line. So we have this part is -1 minus 2 root 17, and then this part is -1 plus 2 root 17. So we can make our interval the way it was. So we know to say x is less than this part here. So if I want, let me just write it. Anyways, it's very long. Okay, minus 2 root 17. So this is our first interval. The second interval will have this same one, which is -1 minus 2 root 17 being less than being less than x, which is less than negative 1 plus 2 root 17, and then the last interval will be this side, which is just this. I mean, x is greater than this. You write it this side, x is greater than this. So if you want to be at least to at least not find difficulties when finding the x2 values, x2 I mean range, when you don't want to be finding difficulties, you approximate this. You say, what is root 17? So the square root of 17 is just something like about 4.1. You can just say this is 4.1. So 4.1 times 2, so you can approximate this to be just 8. So you can just say negative 1 minus 8, and then this one is the same answer, meaning 7 less or equal to negative 1 plus 8. Sorry, negative 1 minus 8 is negative 9. So you can say this one is 9. I mean, yeah, this one is negative 9, and then this one is positive 7. Yeah, so you can take them that way, and then you replace the values that you are going to be getting in the intervals, just to find the positive and the negatives here, and then you test them. You see, then once you find those numbers, you come and test them using this quadratic equation. So these are the critical points that were found. So let's say, for instance, when you get something that is less than negative 9, meaning you get negative 10, you come and replace it in this quadratic equation. If the condition agrees to say the answer that you get this side is greater than 0, then you mark it. If it's this part which has agreed, you do as this, you mark. If it's this part which has agreed, you mark. And then you just write the ranges which have agreed with this condition here. Then after finding your answers here, you just come and find x1, oh sorry, this is x2. You find x1 intersection x2. You find x1 intersection x2, then that is going to be your final solution. Yeah, so same applies to this question here. This question, you also do the same. You first find the positive part of this question like this. You write them separately. You first find the positive part, and then the negative part, you solve them, and then once you solve them, come and find the intersection between x1 and x2. Then you are done with the question. So this one is also simple. This one is also simple. You can also do the same. So you can say x plus 1 plus x minus 2 less than or equal to 5, and then you say x plus 1 plus x minus 2 is less or equal to negative 5. Then you do the same. So x plus x, there you get 2x, and then you have 1 minus 2 there, you get negative 1 less or equal to 5. So x, when you take this to the other side of the equal sign, you are going to have, okay, take negative 1 that side, you are going to have 2x being less or equal to 6. So meaning the value of x will just be less or equal to 3. And then this other part again, you get the same thing, 2x minus 1 less or equal to negative 5. So when you take this to the other side of the equal sign, you have 2x being less or equal to negative 4. When you divide both sides by 2, you get negative 2. So we know to say x is less than 3 and the x is less than negative 2. So you can call this x1 and x2. So meaning to find the final solution, now what you do is, let me just do this. So this interval can also be written as x1 is equal to from negative infinity up to where? Up to 3. So applies to this part here. You can also write it as x2. Sorry, this is x2, not x1 again. So this is x2. So you can say x2 is equal to from negative infinity up to negative 2. So now you find the x1 intersection x2. So x1 intersection x2 is the final solution. So the final solution will now be equal to, so we know to say negative infinity up to negative 2 can also be found in x1. So our intersection is just going to be this same expression here, because this one is smaller than this one. So this one is the intersection. So that's our final answer. Negative infinity up to negative 2. Yeah, so this is basically your solution for that question. You can even try to test it. Put any number that is negative there. So we put negative 3 there. So you say negative 3 plus 1, you get negative 2. And you have negative 3 minus 5. You get negative, negative 3 minus 5, you get negative 5. Sorry, negative 3 minus 2, you get negative 5. So when you add the 2, you get negative 7. Is negative 7 less than 5? Yes. So this implies that our solution is correct. Alright. So thank you very much for watching today's tutorial. See you in the next tutorial video. And make sure that you subscribe to the channel if you have not yet subscribed to the channel. Shalom, shalom.